Hello，大家晚安。大家晚安。那我们现在先等大家陆续加入哦。大家都吃过晚餐了吗？先进来的朋友可以稍等一下哦。那我们等听众陆续进来。好，大家，我们大概会在8:05的时候正式开始。那如果需要去洗手间、上个厕所，或者是倒杯水的朋友们，可以先稍作准备。好，大家今天的活动非常的精彩，绝对不能错过。那么大家今天的主题啊是 AI 时代下的大脑升级策略。那其实啊 AI 这个主题啊现在啊已经非常多人在讨论了，大家可能在讨论着 AI 未来怎么发展啊，然后讨论着接下来可能还会有什么新的科技出现。那今天我们会把 AI 这个主题带回到我们自己本身。那当我们现在面对这么复杂的未来，以及未来面对这么复杂的挑战，我们自己应该要怎么样去准备？那大家，我们今天的活动啊，会分为上下2个半场。那上半场呢，我们会邀请到密涅瓦的创校教授 Diamond 教授为我们发表一段演说。那么，为了方便大家理解，其实工作人员团队已经事先帮大家上好了中文字幕，所以等等大家只要尽量的享受演讲就可以了。好，那么下半场的活动啊，也绝对不能错过。下半场活动非常精彩。那下半场活动啊，我们邀请到了世界观学院的创办人李嘉达老师，以及维格国际学校总校长李海硕校长，以及HAHOW的创办人江前伟执行长，为我们带来对谈以及分享。好，大家，我们活动准备要开始喽，所以大家可以最后再确认一下，说自己是不是已经上完厕所啊，已经完成倒杯水的。好，也确认一下自己的声音跟画面是不是清楚。好，一直陆续有观众进来哦。确认一下说开始准备，还有邀请，欢迎都陆续。
of Graduate Program. Welcome. I'm Professor Geneva Stein, Director of Graduate Programs at Minerva University. I am privileged to introduce today's talk and to bring Professor Alexis Diamond's expert insights to a talented Taiwanese community. This talk and follow-up discussion is a collaboration between Minerva University, our respected partner Worldviews Academy, and HAHOW, the largest online learning platform in Taiwan. Before we begin, I want to state my appreciation for our Taiwanese alumni's work in bringing a focus on critical wisdom to a broader audience through their advocacy and Worldviews Academy courses. We hope to have many more talented Taiwanese professionals join our growing community of learners. Chata Li, founder of Worldviews Academy, and Haishuo Li, superintendent of Wagger International School, whom you will hear from after Professor Diamond's talk, are excellent examples of dynamic changemakers who are now better equipped to innovate and address challenges in their work after completing our master's program in decision analysis. At Minerva, we develop future-focused leaders who are able to make evidence-based decisions that account for the complexities of our ever-changing world. We do this by focusing on a set of core skills and applying those skills across diverse contexts. Many, if not most, of these skills can be harnessed to effectively adapt to the AI era. To talk more about this connection, I introduce one of Minerva University's founding professors, award-winning political economist, Dr. Alexis Diamond.
Hi, My name is Alexis Diamond, and I'm a professor of computational science at Minerva University. Thanks for joining me today. Imagine waking up tomorrow in a world where 90% of the coding and software development jobs of today do not exist. These coding jobs, some of the very best jobs available today, have vanished. Why? Because of AI, because of ChatGPT. This is the vision of a future world that people like Bill Gates and NVIDIA CEO Jensen Huang are now talking about. For example, Jensen Huang made shockwaves a few months ago when he was on stage and he said, "Don't teach your kids to code. They don't need to know how." Here, listen to Jensen Huang explain it at the World Government Summit in Dubai.
I want to say something, and it's going to sound completely opposite of what people feel. Over the course of the last 10 years, 15 years, almost everybody who sits on a stage like this would tell you it is vital that your children learn computer science. Everybody should learn how to program. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program, and that the programming language is human. Everybody in the world is now a programmer. This is the miracle of artificial intelligence. The countries, the people that understand how to solve a domain problem in digital biology or in education of young people or in manufacturing or in farming, those people who understand domain expertise now can utilize technology that is readily available to you. You now have a computer that will do what you tell it to do. It is vital that we upskill everyone, and the upskilling process, I believe, will be delightful, surprising.
Okay, Jensen Huang, what does this world of the not too distant future actually look like? Is anyone still a professional programmer? Sure, of course, yes, there are still professional programmers. Professional programmers are essential whenever investments are massive and coding mistakes can be catastrophic. So they work for governments. In the USA, they work for agencies like NASA and intelligence and defense agencies. They work for hedge funds and finance firms running their own proprietary trading systems. And a few work for companies that create software for scientists and engineers, because when you're designing, manufacturing, or manipulating very complex systems like the human genome or a quantum computer, investments are massive. Mistakes can be catastrophic. One more place that you'll find professional programmers is obviously in AI. Professionals are needed to code the next generation of GPTs. It's professional coders that are going to take us to GPT-10 and beyond. According to Jensen Huang, most people should not bother learning how to code. Huang says that instead, people should focus on what he called domain expertise. If you want to solve problems in farming, he said, then you should really understand farming. And if you want to solve problems in publishing or real estate or gaming or private education or even professional sports, really focus on understanding those businesses. According to Jensen Huang, you don't have to bother with computer science and coding. Your computer will soon be so clever, you will only have to talk to AI, and AI will understand you, and AI will deliver the answers that you need. And if you really require code for some reason, just tell the AI what you need, and AI will give you any code in any language. And it will provide all necessary instructions to use the code, just like an idiot-proof set of IKEA assembly instructions. And in fact, to some extent, this is already happening. The internet is full of videos and posts like these. Huang's message is, become an expert in your area. Be yourself. Be human. And AI will be there to take care of the rest. Huang's reaction reminds me of how some teachers reacted when calculators first became cheap and plentiful. I'm old enough to remember that, when you could buy a small calculator for only a few dollars, and every child could take such a calculator to school. Back then, some teachers in the USA thought it was no longer so important to teach people how to add, subtract, multiply, and divide. When spell checkers and grammar checkers became available, some people said that knowing spelling and grammar wasn't particularly important either. So, the future Huang described is already starting to happen. People across society are already starting to use AI to get answers, solve problems, and make decisions. And this is early days when AI is relatively young. AI is just going to get better and better and better. Today, ChatGPT, for example, makes occasional mistakes on simple mathematical questions. Even just simple arithmetic like subtraction, it makes mistakes with questions that have clear right and wrong answers. I use ChatGPT sometimes to help my teenage daughters with their high school math homework. So I see these types of AI math mistakes a lot. With time, mistakes like these will basically go away. In a short time, perhaps even less than a year from now, AI will be, for all intents and purposes, very reliable for well-posed, formal mathematical questions. But there's one big problem, an important problem, and Jensen Huang didn't talk about it. The problem is that most people with real-world challenges are not ready, not trained to, first of all, ask their questions effectively, and second of all, evaluate AI answers and interpret AI answers correctly. The potential for AI to support real-world, everyday problem solving and decision making is truly mind-blowing. But most human minds are not ready to harness that potential because AI favors the prepared mind. And most people's minds are not prepared. You see, effectively communicating with AI is going to require expert training. Not expert coding, but training. Most people who will go to their AI for help with complex real-world problems and decisions will fail to ask their questions correctly. And if somehow that communication going out to the AI succeeds, well, untrained people will be likely to fail to correctly evaluate and understand the AI's answers. Stop for a moment and think about it. If you're facing a tough challenge or problem and you decide to seek help by talking to another smart human being, what's the probability that this human being is going to really, really, truly understand your problem, your complex problem? Is that probability 50%, maybe less? And that's when you're talking to a human, not a machine. And when you go to some expert, human, who gives you technical advice, maybe it's advice about managing your money or fixing your house or running your business, how often do you find the advice confusing or even contradictory? Fairly often, right? And again, that's with another human. Would you expect an AI to be better at understanding you or able to provide clearer and better advice than an expert human being? The sad reality is that communication is just very hard. And real-world problems are much harder than textbook problems. When it comes to communicating about complex real-world problems and solutions, effective two-way communication is extremely hard. Whether the expert you're asking is an AI or a smart human, you have to be wise, you have to have relevant knowledge, and you have to be able to communicate effectively. As a professor at Minerva University, my job is to prepare my students' minds for complex real-world decision-making. My students are trained to frame their questions and problems wisely, correctly, defining their goals and their constraints. They're taught many methods of analysis, how to choose the right method for a given situation, and how to use and interpret results correctly. And they are taught to think critically about claims and evidence. I teach a year-long class focused on logical thinking, computer science, statistical reasoning, impact evaluation, and decision-making. My focus in every class is the real-world relevance of what we're learning. Everything I teach is a kind of practical wisdom. I'm always emphasizing practical wisdom. That wisdom, like most wisdom, shines light on things that are crucially important, but invisible, unknown, and ignored by most people. Because we focus on these things at Minerva, our students' minds are prepared. If they face a decision problem, surely they're going to engage with smart people for advice and productive discussion. And because it's now the age of AI, they are also going to engage with smart AI, also for advice and productive discussion, possibly even for some code. The key is that because my students have the right training, they are prepared to make the most of these engagements, whether the engagements be with AI or smart humans. Let me give you 3 concrete examples of the kinds of challenges and problems that we discuss in my class to help my students prepare for real-world success. My first example is a lesson about how difficult it is to say what you mean. We tend to think that the people around us understand us perfectly, even when they don't, even when we are all native speakers of the same language. This is true even when the words are simple, the concepts are simple, and people are trying hard to be clear. The difficulty of communicating is so obviously true that examples are plentiful. For example, have you ever heard the joke about the panda who walks into a bar? It goes like this. A panda walks into a bar. He orders a sandwich, eats it, then pulls out a gun and fires 2 shots in the air. Why? Asks the bartender, as the panda moves towards the exit. The panda produces a wildlife manual and tosses it over his shoulder. I'm a panda, says the panda. Look it up. The bartender picks up the wildlife book, flips to the page on pandas, and sure enough, finds an explanation. The page says, panda, large, black and white, bear-like mammal, native to China, eats, shoots, and leaves. Get it? The punchline of this joke is the final sentence, eats, shoots, and leaves. We all know that pandas eat shoots, bamboo shoots, and leaves. But the way it's written gives the panda the idea that he's supposed to eat, then shoot, and then leave. Yes, communication is hard. Hard for pandas, hard for people. Just ask the milk company in the United States that lost a $5 million lawsuit in 2018. The company had to pay milk delivery drivers $5 million in overtime payments for distributing milk. You see, the law in the state of Maine had been intended to exclude such overtime payments. The state of Maine wanted to say you couldn't get overtime payments for distributing agricultural produce. But the letter of the law was unclear. The letter of the law was as follows. It said, we're going to exclude overtime payments for, and here we go, for the canning, processing, preserving, storing, packing for shipment or distribution of agricultural produce, meat and fish, etc. In court, the milk drivers said that because there was no comma after the word shipment, the sentence did not exclude overtime payment for distribution. The milk driver said that the law only excluded overtime pay for packing, and only then if the packing was for shipment or distribution. All because of a comma. The milk drivers won their case. And soon afterwards, the state of Maine quickly changed the wording of the law and added that comma. Well, everyone knows that punctuation marks can be confusing. Few people realize how confusing simple words, everyday words, can be. Most of us won't communicate accurately and precisely unless our minds are trained specifically to do so. Consider the following sentence, which I once saw in a letter that one company sent another. The sentence reads, quote, "If you don't sign the form attached to this email, then I will file a lawsuit against you." Looks like a simple sentence. What does it say? It says, quote, "If you don't do X, then I will do Y." Now reread that sentence and ask yourself, how can the recipient of the letter stop the sender from filing a lawsuit? I'll say it again. How can the recipient of the letter stop the sender from filing a lawsuit? It's tempting to say, to stop the lawsuit from happening, the recipient must sign the attached form. Tempting, incorrect. Actually, the sentence does not tell us how to stop the lawsuit from happening. Let's read that sentence again. If you don't sign the form attached to this email, then I will file a lawsuit against you. The sentence only tells us how to trigger the lawsuit. We can be sure that the lawsuit will happen if the attached form is not signed, but we can't be sure that signing the attached form will stop the lawsuit from happening. The sentence is silent about what will happen if the form is signed. In my classes on deductive logic, we call sentences like these conditional sentences, and this example is actually one of the simpler cases. Consider the following two sentences. Sentence 1, if you do the job, then I will pay you $100,000. Sentence 2, I will pay you $100,000 only if you do the job. Most untrained people would say that these sentences appear at first to be very similar. You could even imagine a human explaining a situation or having a conversation using either sentence interchangeably to mean the same thing. But it turns out that they are not the same thing, not at all. The shocking thing is they don't even mean remotely the same thing. Someone whose mind is trained and prepared to think logically would know sentence 1 is the converse of sentence 2. What's the practical difference between these two sentences? Well, sentence 1 can be simplified as if job, then paid, or job, arrow, paid, right? This sentence does not say anything about what happens if you don't do your job. Sentence 2 says that the only way you get paid is if you do the job. In other words, if you got paid, you must have done the job. So the symbolic representation of sentence 2 is actually paid and then an arrow pointing to job. If paid, then job. Let's review. Sentence 1 is, if you do the job, I will pay you $100,000, and that's job, then paid. Sentence 2 is, I will pay you $100,000 only if you do the job. So sentence 2 is paid, then job. In class, we would make time to practice and probably role play this case. We would identify situations where these sentences do and do not lead to the same conclusions. We won't go down that rabbit hole today. But notice, even when your sentences are very simple, like these two sentences, and your words are very simple, you can make mistakes, especially if you're talking to an AI that does not make logical mistakes. By the way, in a Minerva class, we would never, ever lecture like I'm lecturing today. Because if I lecture too long, you will tune out. I can really hold your attention at best for 3 or 4 minutes maximum. Even if I do things like surprise you, or I whisper and you wonder what I'm talking about, so you tune in. Or I tell a joke and I make you laugh. Even if I do tricky things like that, to grab your attention, 3 or 4 minutes of lectures, your mind will start to wander. And if your mind wanders in a math class or a computer science class, you can easily and quickly get totally lost. So at Minerva, there are no lectures. We are calling on students, engaging them directly all the time. If you're in a Minerva class, then you have to be ready to be called on. A Minerva classroom can be a little stressful at first, but a little stress, the right amount of stress, is not a bad thing. It helps you focus. Now, let's return to those examples, and we will move now to example 2. Let's move from challenges with sentences to challenges with data and evidence. Imagine that you just hired a new employee, and he made a poor decision, unfortunately, which created a costly problem. In fact, the problem has created a crisis at your company, and now you are worried. Maybe the new guy you hired wasn't even qualified. Is he unqualified? You're wondering if you just accidentally hired someone who wasn't qualified. And if he is not qualified, then you know that unfortunately you should probably fire him, because you cannot invest in training and there are other qualified people available to hire. So you think about it. You know that the bad decision he took was a decision that an unqualified person could easily have taken. But is that enough information to decide, yes, he must have been unqualified? Now, I have never seen this question in any textbook, but if you have had the right training, you would recognize that this question is a lot like questions that actually are in textbooks. It turns out that this question about the employee, qualified or not, is a lot like a classic biostatistics question. And here is that classic biostatistics question. It has to do with a patient takes a test. Okay, if we have a patient tested for some disease, and the test correctly identifies sick people 99% of the time, correctly identifies sick people 99% of the time, then what should a patient conclude if her test result is positive? The answer to this question about the medical test seems rather obvious, right? But it's not so obvious, in fact, because we're missing important information that we need. In fact, if you really understand this question, then you know that it's entirely possible that the positive medical test means that the patient probably doesn't have the disease. It's possible. I'm not saying has to be. I'm saying I can construct a problem where a positive medical test means the patient probably doesn't have the disease. And it's even possible that a positive medical test in this case means a 99% chance the patient doesn't have the disease. Now, we'll return to this medical test situation in a moment, but first, back to the case of the unfortunate employee you hired. In the case of the employee who made a mistake that an unqualified person could easily make, well, we are also missing important information there. We don't have enough information to decide whether it's more likely than not that the person is unqualified. To explain this fully and deeply would take an entire 90-minute class session. But consider, what important information is missing when it comes to the story of our unfortunate employee? Well, in this case, we said that he made a mistake that was likely for an unqualified person. But what we don't know is how likely his mistake was for qualified people. For example, if this mistake was just as likely to occur to someone qualified as someone unqualified, then the mistake tells me nothing about this employee's qualifications. Nothing. But if I think that this mistake was much more likely, like twice as likely, to occur to an unqualified person, then witnessing this mistake should make me much more confident that the candidate was unqualified. If I want to think in terms of probabilities, like what's the probability he's unqualified, now that I know he's made this mistake, well, then I have to estimate some numbers, but I can do that. We learn in my class how to do that. And the reasoning involved is called Bayesian reasoning. It's the scientific way to update our understanding by observing evidence. In this situation, having a mind trained to think in a Bayesian way reminds me to ask myself about the probability that a qualified person might make this mistake. And that's really good. It makes me wiser. Because in a crisis situation like this, it's very easy to simply jump to the conclusion that the guy must be unqualified. It's easy to jump to that conclusion and forget to weight the probabilities of other explanations that can also fit the facts. In the medical test example, the same sort of logic applies. We know from surveys that regular people, even very smart, highly educated people, don't know that medical tests, like the one in the example, are often wrong. Even tests that correctly identify people who have the disease, that correctly identify people with the disease 99% of the time, may deliver the wrong answers less than half the time, or less than even 1% of the time. It sounds very confusing, doesn't it? How is that possible? Here's an example. Let's imagine we're talking about some rare disease. Maybe only 1 out of 100 people tends to have this disease. And while the test identifies sick people who have the disease, it identifies them correctly 99% of the time. Let's imagine that it also wrongly reports healthy people have the disease 10% of the time. So, for example, if we had 100 healthy people, then the test would wrongly say that 10 of these healthy people have the disease. Now, what happens when 100 people in the general population are tested? Well, remember, it's a rare disease, right? In the general population, only 1 person out of the 100 has the disease. And because this test gets it right for sick people with the disease 99% of the time, that 1 sick person out of 100 almost certainly is going to test positive. But there's also 99 other tests for the 99 healthy people in the sample. And about 10 of them are going to show incorrect positive results. So out of 100 people tested, we're going to have about 11 positive results, only 1 of which is a true positive. So what should a patient think if her test result comes back positive? The patient should think that her probability of having the disease is a little less than 10%. It's like approximately 1 out of 11. It's not good news, but it's not as bad as most untrained people would guess. In fact, it takes a lot of mental training to know how to ask the right questions when interpreting data, like in these examples. It also takes training to deeply understand the answers. If you have this training and your mind is prepared, then you are ready to do what Jensen Huang said. You will be able to express the key parts of your questions with anyone, machine or smart human, and you will be able to correctly evaluate and understand the responses you get back and any code as well. If you don't have a prepared mind, you will probably ask the wrong question in the wrong way, and when you get a response back, there's a good chance you'll be confused, go down the wrong path. Let's walk together through one more example. This one is about impact evaluation. Everyone cares about impact, right? Knowing how to think about impacts can be a real superpower. Here's an example that I like to discuss in my class every year. Let's assume your senior management is trying to decide whether or not to shut down a program or keep it going. Well, there were 3 units in the program. 2 units had successful outcomes and 1 unit failed. I'm going to repeat that. It's very important. There were 3 units in a program, 2 successful, 1 unit failed. And a unit here may sound very mysterious, but it can be a person, it can be a product, it can be a team, it can be a company. A unit is a unit, it can be many different things, whatever you happen to be imagining. Now, management wants to know what, if anything, can be concluded about the impacts of this program. And they come to you for help because you have a reputation for practical wisdom. Can we say anything about the impacts of the program? What would a textbook say? Well, a textbook might say, to identify impacts, you need a treatment group and a control group. Do we have that here? Nope. We only have a treatment group. What might ChatGPT say? It might say, in order to calculate impacts, you need a randomized controlled trial with a large data set. Do we have a randomized controlled trial with a large data set? Obviously not. What might a smart coworker say? Well, a smart coworker might say, oh, 2/3 of them were successful, so the impact of being in the program should be estimated as positive 2/3. And by the way, did anyone notice that there is some important wording that was different in each of these sample answers? The first answer talked about identifying impacts. The second answer talked about calculating impacts. The third answer talked about estimating impacts. These words may sound almost the same, but someone who's been trained knows that identification, calculation, and estimation are actually all different things. Which one did you want? Which one does the senior manager want? Which one are you going to ask AI about? And to answer that question, you would have to know what each one is. Anyway, when presented with this problem of 2 successes and 1 failure for 3 units in the program, a student trained in my class should know that it's impossible to be precise about the true impact in this case. But that student would also know that this is not a problem unique to this case, because we can never, ever be precise about true impacts. Even in a randomized experiment with a treatment group and a control group and a large sample size, we won't know the true impact with certainty. A student whose mind has been trained to think correctly and deeply about cause and effect, what is called causal inference, would know that the impact here is going to depend upon something called the counterfactual. A counterfactual is the outcome that would have happened without the program. So impact here depends upon what would have happened to the 3 units had they not been part of the program. We call this the counterfactual scenario for the 3 units. And we ask ourselves, could they have succeeded without the program? Could they have failed without the program? I'm sure it's obvious to you that these counterfactual outcomes are outcomes we can imagine but never observe. We can never observe the counterfactual for these units because by definition, the counterfactual did not occur. It's why we call it the counterfactual. Now remember, the question before us was, what is the impact of the program on these units? It might surprise you to learn that the right way to answer this question requires the power of your imagination. First, let's walk through the simplest case. Imagine that the counterfactual potential outcomes for the 3 units are all exactly identical to the observed outcomes. What were those observed outcomes? Oh yes, 2 successes and 1 failure. So, once again, imagine that the counterfactual potential outcomes that you didn't get to see were exactly the same as the observed ones you did see. Well, then being in the program makes no difference to the outcomes. No difference in outcomes being in the program versus not being in the program. This must mean the program, in such a case, would have absolutely no impact. In such a case, the program doesn't move the needle on outcomes at all. I'm not saying that the program had zero impact. I'm just saying I can imagine a scenario for the counterfactuals that's consistent with zero impact. In other words, I conclude that the evidence that we saw could mean zero impact. Could. Zero impact is a possibility. Remember that. Now let's imagine another and totally different case. Imagine that the counterfactual potential outcomes for the 3 units happen to all be failures. Let's call a failure a 0. Let's call a success a 1. So 3 failures is 3 zeros. 0, 0, 0. What's the average of 0, 0, 0? What's the average of these imagined counterfactual outcomes? Well, the average is just 0. The average counterfactual outcome in this case we're imagining is 0. All right, now the observed outcomes. The observed outcomes were 2 successes and 1 failure. We're calling failures zeros. We're calling successes ones. Then the average observed outcome is 2/3. The difference between the average outcome with the program, 2/3, and the average counterfactual outcome that we're imagining, 0, is just 2/3 minus 0, which is 2/3, of course. It's this difference in outcomes with the program versus without the program that defines program impact. This teaches us that if the counterfactual outcomes happened to all be 0, well, then the average program impact would be 2/3. In other words, if all 3 units happened to be failures in their counterfactual scenarios, then the program moves the needle on average by positive 2/3. And that's the upper bound, the maximum of impact that is humanly possible given the observed data for these 3 units. That's the upper bound on the average impact for the 3 units. It's what we get if we imagine that the counterfactual scenarios are worst possible, where all 3 fail without the program. So remember that. The extreme upper bound on average impact is positive 2/3. And remember, from the first case, we know 0 impact also was a possibility. Is negative impact also a possibility? And how would we get the extreme lower bound on impact? Well, we should imagine the opposite of what we did a minute ago. A minute ago, we imagined the worst case counterfactual scenario, all zeros. But now imagine the opposite, imagining the best possible counterfactual where all 3 units had succeeded without the program. Well, we could represent that as 1, 1, 1, 3 successes. The average of these imagined counterfactual outcomes is just 1. And if this counterfactual were true, guess what? Then the program actually has a negative impact. If this counterfactual were true, then the units are doing worse on average with the program than they were without the program. Wait. 2 out of 3 units are successful, but the project actually could be having a negative impact? Absolutely, it's possible. The impact in this scenario, the extreme lowest bound of the average impact, is obtained by comparing the average observed outcome, which is 2/3, to the average imagined counterfactual outcome in this case, which is 1. 2/3 minus 1 implies an average impact of negative 1/3. 2/3 minus 1, negative 1/3. Negative 1/3 is the extreme lowest bound average impact for our 3 units. Now this may seem a little strange because 2 out of 3 units here are succeeding, and we're saying that negative impacts are possible, but it's absolutely possible. maybe an analogy would help. It's just like a situation in which all the students in a class get A's as grades, but the teacher could actually have a negative impact. Because whenever you're talking about impacts, it all depends on what you think the counterfactual might be. And if the counterfactual happens to be a different teacher with whom the students get A's and also some A pluses, then the impact of the teacher who only delivered all A's is actually bringing that class average down and therefore having a negative impact. If you want to argue that negative impact is impossible, then you have to persuade me that certain counterfactuals are impossible. ChatGPT or AI might be able to help you make an argument like that, but you would have to know to ask for that argument, and you would have to understand how to use that argument if you managed to get the necessary facts. Sometimes I present this problem with 2 out of the 3 units successful on the very first day of my class, before my students have been trained to think about impacts correctly. So I know from experience that if people who have no training are presented with this problem, they almost always get it wrong. If you don't know that program impact is about observed outcomes compared to unobserved outcomes for the same units, then it's game over for you. You can't even ask the right questions, let alone evaluate and understand any answers. In this case, the right answer is the evidence is consistent with any average impact of the program between negative 1/3 and positive 2/3. If your mind was not trained to think about impacts in terms of potential outcomes, you will never get to this answer. And if somehow, by some miracle, you did get to this answer, maybe you got some help from AI, you wouldn't be able to explain it to your managers. Those are my 3 examples. The example with the sentences, the example hiring the employee who made a mistake, and the example evaluating the impact of a program. All 3 examples are specific, concrete examples of important challenges that matter in real life and that most people ignore. If you want to communicate effectively, interpret evidence correctly, and evaluate impact correctly, then you have to practice, train, and prepare your mind to do so. It doesn't come to us humans naturally. At Minerva, we call these ways of thinking habits of mind. These habits of mind must be learned, coached, and deliberately practiced. That's what happens in my classroom. I fully expect my students to ask AI for help solving these kinds of problems, but my students are able to do so only because they fully understand the complexity of these problems. Our students know what questions to ask. Our students know how to craft the sentences to ask these questions correctly. Our students even will know what code to ask for, and they will be able to evaluate the answers and the code they get back because why? Because they have trained for it. Our students have the expertise and the sophistication to use all their tools and resources effectively, reliably, responsibly, and professionally. Thank you very much.
好，大家听完Diamond教授的分享，有没有什么心得呢？都可以在聊天室跟我们交流跟分享哦。大家可以分享说，你刚刚听到的最印象深刻的，还是最特别有记忆的，都可以在聊天室跟大家交流互动。另外啊，大家如果对于密涅瓦大学有兴趣，想要收到密涅瓦大学完整的思考清单，以及密涅瓦大学更详细的讯息说明，都可以聊天室我们都有丢表单。那大家如果填写表单的朋友们，未来都有机会收到更多有关密涅瓦大学的资讯。好，那大家刚刚听完一阵子，我们待会会稍微休息一下。那接下来我们会进入下半场的准备阶段，我们预计在9点整的时候准时开始。那么在这段时间，大家如果要上个厕所或倒杯水的，都可以在这段时间稍作休息一下。那么下半场的活动啊， 大家更是精彩，大家绝对不能错过。我们下半场啊，会由世界观学院创办人李嘉达老师，以及维格国际学校总校长李海校长，以及